Okay, section 1.7 talks about exponents, algebraic expressions, and order of operations. So talk about section 1.7. We're going to be talking about exponents, algebraic expressions, and order of operations. Okay. First, when we talk about exponents, it's simply the repeated multiplication of the same number. And we could talk about the notation. So for exponents, it's simply the repeated multiplication of the same number. So, for example, if I have 3 times 3 times 3 times 3 times 3, right? I'm multiplying 3 5 times. The notation we use is 3, and then we have the superscript, which we call the exponent, to the 5th power. The 3 is called the base. That's the number that's being multiplied. And 5 is the exponent, which tells you the number of times it's being multiplied. And we can also say that this is 3 to the 5th power. Okay. This notation here, if we had say 5 to the 2nd power, we could also say 5 squared to the 3rd power. These are special again, it's 5 cubed. And then once we get beyond an exponent of 3, we simply say 5 to the 4th power. And then just as a note, so we've talked about 2, 3, and 4. Any number that doesn't have an exponent is assumed to have an exponent of 1. So any number without an exponent has a power of 1, meaning 5 is simply the same as 5 to the 1st power. Okay? So let's just do a couple of examples. If I ask to evaluate 6 squared, or 6 to the 2nd power, that's simply 6 times 6, which is 36. Right. 5 to the 3rd power means you take the number 5 and you multiply it by itself 3 times, because that's what the exponent tells us. And that gives us 125. 2 to the 4th power means I take 2 and I multiply it by itself 4 times, which gives me 16. Okay, notice that, so these are all your regular numbers, your regular bases with any integer exponent, right? Notice though, if our base happens to be 10, let's take notice of this. Right. For powers of 10, meaning my base is simply 10. 10 to the 1 is 10, right? 10 squared is 10 times 10, or what? 100. Right, notice this has 1 0. Notice this has 2 zeros.
10 to the third.
10 times 10 times 10, which is 1,000, which is 3 zeros. So you can imagine 10 to the 9th is going to have how many zeros? Right, so we're going to have 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 zeros. So for the powers of 10, the exponents indicate the number of zeros after 1. Okay? Okay, the next thing we're going to talk about is square roots. And we have another symbol for square roots. We use something that looks a little bit like a division sign, but it's got a little hook on it. And that's a symbol for a square root. And we call this the radical sign. Okay, so if we think about the square of a number, so for example, we were using the example 5, right? 5 squared is 5 times 5, which is 25. Okay, the square root of the number is kind of like the opposite. It's basically the opposite of squaring a number. Okay, so if I ask you, what is the square root? So I'm saying the square root of 36. What is the square root of 36? I have to ask myself, what number multiplied by itself gives me 36? And if I know my multiplication tables really well, then I know that that's simply going to be the number 6. So it's going to help a lot to know your perfect squares. So know your perfect squares. I'd say up to about 13. And then you want to know maybe 15 and 25. Those are all convenient ones to know. Okay. So basically these are the, it's like on the diagonal of your multiplication table. Okay, so we know 1 squared is 1, right? These are my perfect squares. 2 squared is 4. 3 squared is 9, right? Keep going. 6 squared is 36, right? 9 squared is 81. So these are all my perfect squares. 1, 4, 9. If I did 4 squared, I get 16. 5 squared, I get 25. These are all good numbers to know. Okay. So in contrast, when I take the square root, if I ask you the square root of 25, what number times itself gives me 25? 5. And what number times itself gives me 121? 11. Okay? So you can see how these are just opposite operations of each other. How about this one? What's the square root of 1? 1, right? 1 times itself gives me 1. What's the square root of 0? 0. Right? 0 times itself is still 0.